Woohoo! Let's do some composite functions here, folks. So this is the directions. Well, directions are find the indicated operation, perform them. And this is what we're doing. We're finding g of f of x. Start from the inside. X is our variable. That's our input in the f function. Give the f of x a hug. This f of x is now our input in the g function. So I want you to please give the f of x function, the value, a hug. So I'm hugging f of x. This is going in place of x, the independent variable or the input variable. This whole thing is going in place of x in the function g. So I'm going to arrow up and say, hey, this is going in place of the x. So it's 2 times whatever f of x is. It's that whole function that's going in place of x. See how what I wrote down here looks exactly the same as the g of x function, but its input value, its x value, is now this whole function. That's the new input. And so now we simplify this, folks. We distribute the 2 everywhere here, so we get negative 6x and minus 6. Of course, we don't distribute it beyond the parentheses. We bring down the plus 2, and now we can combine like terms. We have negative 6x minus 4. Boom. Let's try it on number 2. And this is weird, folks. I remember being in your shoes in high school. I don't know what just happened, and it's different. Hang in there, you can do it. So start at the t, then go to g of t. Give it a hug, and give your actual g of t function a hug. Put parentheses around it. This g of t function, this 2t minus 1, is your input in the function f. So this 2t minus 1 goes in place of the t. It's your input. So I'm putting 2t minus 1 in place of t. And then, notice there's no multiplier with it. We're not multiplying t by anything. So I don't have to multiply this stuff by anything. But I'm going to subtract 2 from it. And then we combine like terms. Negative 1 and negative 2 makes negative 3. Why does that keep happening? Sorry. There we go. Ha! Whoa. Things are acting funny. Hey, buddy. You bet. So then, we're going to take the f of a function, give it a hug, and then please give it a hug, and then arrow it over to, is that right? All right. No problem. And then arrow it over to your g function, because f of a is the new input in place of a in the function g. So there we go. We're going to take 4 times the new input. We're going to take 4 times this f of a function. So 4 times, in parentheses, a squared plus 4 minus 5. So now we get 4a squared plus 16 minus 5. We get 4a squared plus 11. There we are. All right, so again, start from the inside. So we have a is our variable that we're dealing with. I'm glad I see a's all around. Now g of a is going to become your input in the h function. So hug your g of a. By the way, folks, if you've been noticing that it's always the second function going in for the top one, that's random, or it's lucky, or it's coincidence. So you really want to make sure that you understand that you start from the inside out. So it's this function with parentheses around it going in place of the variable for the h function. So this goes in place of a. So I have 3a squared minus 1, and I'm not multiplying it. So actually I don't even need the parentheses, because I'm not, if I'm multiplying a by something here, or squaring it or doing something, I need to make sure I have parentheses around the entire g of a function, so I do that multiplying or squaring to the whole function. I don't just pick on one part of it or not the other part of it. But I'm not multiplying or powering that or dividing that. So I'm just adding 2. I'm adding 2 to my input, to my g of a function. And then simplify that. So you get plus 1. Bada bing, bada boom. 3a squared plus 1. Ooh, this one's fun. So here, this is my g of n is my input. So I'm putting parentheses around it. But it's going in place of n, my variable, for the function g. So this is my new input for n in the function g. So my input is 4n plus negative 4n plus 4, and that's going in place of n in this function. So I'm going to copy this function down, but instead of putting down n, see how I didn't highlight the n there? I'm going to input the g of n function. And g of n is, check it out, it is negative 4n plus 4. I end my parentheses and I add 4 to the end of that. So now we distribute, we get 16n minus 16 plus 4. Combine your like terms, you get 16n minus 12. Boom. Last one, folks. Go from the inside out. So g of n is going in place of n in the function h. So I copy down the top function, but in place of n, I put n squared minus 2, and then I subtract 2. So we distribute, we get negative 3n plus 6, and then we subtract 2, 3n squared. So we get negative 3n squared plus 4. Boom! Have a good day.